A squall is a sudden, sharp increase in wind speed that is usually associated with active weather, such as rain showers, thunderstorms, or heavy snow. Squalls refer to an increase in the sustained winds over a short time interval, as there may be higher gusts during a squall event. They usually occur in a region of strong mid-level high falls, or mid-level tropospheric cooling, which force strong localized upward motions at the leading edge of the region of cooling, which then enhances local downward motions just in its way. Etymology. There are different versions of the word's origins. By one version, the word appears to be Nordic in origin, but its etymology is considered obscure. It probably has its roots in the words vala and Old Norse word meaning literally to squeal. By another version, it is an alteration of squeal influenced by bull. Character of the wind. The term squall is used to refer to a sudden wind speed increase, both historically and in the present day. In 1962, the World Meteorological Organization defined that to be classified as a squall, the wind must increase at least 8 meters per second and must attain a top speed of at least 11 meters per second, lasting at least 1 minute in duration. In Australia, a squall is defined to last for several minutes before the wind returns to the long-term mean value. In either case, a squall is defined to last about half as long as the definition of sustained wind in its respective country. Usually, this sudden violent wind is associated with briefly heavy precipitation. Regional terms. Argentina, known locally as Pamparos, these are characterized as strong downsloped winds that move across the Pampas, eventually making it to the Atlantic Ocean. Central America. Offshore Central America, a gully squall is characterized by strong increases of the wind forced through sharp mountain valleys on the Pacific Ocean side of the isthmus. Cuba. A Bayamo is a squall emanating from tropical thunderstorms near the Bight of Bayamo. East Indies. In the East Indies, Brubu is a name for a squall. Pacific Northwest. In the Pacific Northwest, a squall is a short but furious rainstorm with strong winds, often small in area and moving at high speed, especially as a maritime term. Such a strong outflow occurring in fjords and inlets is referred to by mariners as a squamish. South Africa. Bullseye squall is a term used offshore South Africa for a squall forming in fair weather. It is named for the appearance of the small isolated cloud marking the top of the squall. Philippines. In most parts of the country, squalls are called subasco and are characterized by heavy rains driven by blustery winds. Local fishermen at sea are often on the lookout for signs of impending squalls on the open water and rush to shore at its early signs. Southeast Asia. Barat is a term for a northwest squall in Manado Bay in Sulawesi, Sumatra. Squall is a term used in Singapore and Peninsular Malaysia for squall lines that form over the island of Sumatra and move east across the Straits of Malacca. Gusts can reach up to 28 meters per second. Severe weather. A squall line is an organized line of thunderstorms. It is classified as a multi-cell cluster, meaning a thunderstorm complex comprising many individual updrafts. They are also called multi-cell lines. Squalls are sometimes associated with hurricanes or other cyclones, but they can also occur independently. Most commonly, independent squalls occur along front lines, and may contain heavy precipitation, hail, frequent lightning, dangerous straight-line winds, and possibly funnel clouds, tornadoes and waterspouts. Squall lines require significant low-level warmth and humidity, and nearby frontal zone, and vertical wind shear from an angle behind the frontal boundary. The strong winds at the surface are usually a reflection of dry air intruding into the line of storms, which when saturated, falls quickly to ground level due to its much higher density before it spreads out downwind. Significant squall lines with multiple bow echoes are known as derecho. Squall line life cycle. There are several forms of mesoscale meteorology, including simplistic isolated thunderstorms unrelated to advancing cold fronts, to the more complex daytime, nocturnal mesoscale convective system and mesoscale convective complex, to squall line thunderstorms. Formation. The main driving force behind squall line creation is attributed to the process of infilling of multiple thunderstorms and/or a single area of thunderstorms expanding outward within the leading space of an advancing cold front. Pressure perturbations. Pressure perturbations within an extent of a thunderstorm are noteworthy, with buoyancy rapid within the lower and mid-levels of a mature thunderstorm. One might believe that low pressure dominates in the mesoscale environment. However, this is not the case, with downdrafts ushering colder air from mid-levels, hitting ground and propagating away in all directions. High pressure is to be found widely at surface levels, usually indicative of strong winds. Wind shear is an important aspect to measuring the potential of squall line severity and duration. In low to medium shear environments, mature thunderstorms will contribute modest amounts of downdrafts, enough to turn will aid in create a leading-edge lifting mechanism, the gust front. In high shear environments created by opposing low-level jet winds and synoptic winds, updrafts and consequential downdrafts can be much more intense. The cold air outflow leaves the trailing area of the squall line to the mid-level jet, which aids in downdraft processes. Evolution. Updrafts. The leading area of a squall line is composed primarily of multiple updrafts, or singular regions of an updraft, rising from ground level to the highest extensions of the troposphere, condensing water and building a dark, ominous cloud to one with a noticeable overshooting top and anvil. Because of the chaotic nature of updrafts and downdrafts, pressure perturbations are important, as thunderstorms fill into a distinct line. Strong leading-edge updrafts, occasionally visible to a ground observer in the form of a shelf cloud, may appear as an ominous sign of potential severe weather. Beyond the strong winds because of updraft-downdraft behavior, heavy rain is another sign of a squall line. In the winter, squall lines can occur albeit less frequently, bringing heavy snow and/or thunder and lightning, usually over inland lakes. Bow echoes following the initial passage of a squall line. Light to moderate stratiform precipitation is also common. A bow echo is frequently seen on the northern and southernmost reaches of squall line thunderstorms. This is where the northern and southern ends curl backwards towards the middle portions of the squall line, making a bow shape. Bow echoes are frequently featured within supercell mesoscale systems. Mesolo, the northern end of the squall line, is commonly referred to as the cyclonic end, with the southern side rotating anticyclonically. Because of the Coriolis force, the northern end may evolve further, creating a comma-shaped mesolo, or may continue in a squall-like pattern. Dissipation. As supercells and multicell thunderstorms dissipate due to a weak shear force or poor lifting mechanisms, the squall line, a gust front associated with them, may outrun the squall line itself, and the synoptic scale area of low pressure may then infill, leading to a weakening of the cold front. Essentially, the thunderstorm has exhausted its updrafts, becoming purely a downdraft-dominated system. The areas of dissipating squall-line thunderstorms may be regions of low CAPE to low humidity, insufficient wind shear, or poor synoptic dynamics leading to frontolysis. From here, a general thinning of a squall line will occur, with winds decaying over time, outflow boundaries weakening, updrafts substantially, and clouds losing the thickness. Signs in the sky. Shelf clouds and roll clouds are usually seen above the leading edge of a squall, also known as a thunderstorm's gust front. For the time these low cloud features appear in the sky, one can expect a sudden increase in the wind in less than 15 minutes. Tropical cyclones. Tropical cyclones normally have squalls coincident with spiral bands of greater curvature than many mid-latitude systems due to the smaller size. These squalls can harbor waterspouts and tornadoes due to the significant vertical wind shear which exists in the vicinity of a tropical cyclone's outer bands. Winter weather. Snow squalls can be spawned by an intrusion of cold air aloft over a relatively warm surface layer. Lake effect snows can be in the form of a snow squall.